Hello everyone and welcome to today's maths class. In today's video, we're going to dive into an important topic in number theory, which is prime factorization. By the end of this lesson, you'll not only understand what prime factorization means, but you'll also be able to break down any number into its prime building blocks. So grab a notebook and let's get started. So, to understand what prime factorization is, we have to focus on the two words that make up this term, prime and factorization. The word prime is linked to prime numbers, and if you don't know what they are, let me break it down for you in simple words. A prime number is a number that can only be divided by 1 and itself. Now, the first few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and 23. Now, if you take a closer look at these numbers, you'll definitely notice this pattern. 2 is the first prime number, and it's a prime number because its only factors are 1 and 2. 3 is a prime number because its only factors are 1 and 3. 5 is a prime number because its only factors are 1 and 5. What about the number 17 or any other number in this list? Is there any number from 2 to 16 that can divide 17? Well, there isn't, meaning it can only be divided by 1 and itself, making it a prime number as well. Now, I always recommend learning these first few prime numbers since it'll save you a lot of time from having to go back and calculating which numbers are prime and which aren't. Now that we have the word prime sorted, what about the second part of this term, factorization? A factor is a number that divides another number exactly without any remainder. For example, if you take the number 12, the factors are 1, 2, 3, 4, 6, and 12 itself. And what about the number 20? Its factors are 1, 2, 4, 5, 10, and 20. So when we say factorization, we mean writing a number as a product of its factors. Now, in order to understand what prime factorization actually is, we're going to combine these two ideas, prime numbers and factors. So, prime factorization is basically breaking down a number into its prime number factors. Or, if you put it simply, it's like asking yourself, which prime number can I multiply together to get this number? There are a few different ways that we can find the prime factors of any number. Some students like using the factor tree. No hate for it, but I would definitely recommend getting used to this other way of doing it. It'll help you out in a lot of other topics, like finding the HCF, the LCM, the square root, the cube root. So, yeah, always be open to the idea of learning a new method as long as it helps you out in the long run. So let's try understanding the idea of prime factorization with an example. Let's begin with the number 40. Write down the number and make lines like this. We're going to start by dividing it with the smallest prime number that it can be divided by, which, if you remember, is the number 2. You can only divide a number by the number 2 if it's even. And in this case, 40 is even, so we're going to divide it by 2. 40 can be divided by 2, and the answer is 20. You're going to write 2 here and then write the 20 here. Now check again if you can divide it by 2 again. Since 20 is an even number itself, you definitely can. So you're going to write 2 over here, and this time you get 10. You have to keep doing this until you get to the number 1. Now divide 10 by 2 again since it's an even number, and you will get the number 5, which you're going to write down over here. Now, since you can't divide 5 by 2, you have to try dividing it by the prime number that comes after 2, which is 3. As you know, 5 can't be divided by 3, so we move on to the next prime number, which is 5. It's pretty obvious that 5 can be divided by 5, and we get 1, which is the answer. So you write 1 here and 5 here. Remember, I told you our ultimate goal is to get to the number 1, which we definitely have. Now that you've written down all the prime factors 40 can be divided by, it's time to write the number 40 as a product of its prime factors. All you have to do is write 40 along with an equal sign. Now multiply all the numbers here. So you get 2 times 2 times 2 times 5. Sometimes this can be your answer. Other times, your teacher can ask you to write it in its exponential form. Without going into the details of this weird word, let me just show you a simple way of how you can do this. Count how many 2's there are. 1, 2, 3. Now write down 2 and put a small 3 on top. Since there's only one 5, you won't really have to do anything with it. So in the end, your answer is going to be 40 is equal to 2 raised to the power of 3 multiplied by 5. And there you have it. We just solved our first question together. But before you run off thinking you've understood this topic, remember, maths is all about practice. So we need to solve a few more questions before we can become a pro. All right, let's try another one together. This time, we'll work with the number 72. So just like before, write down 72 and make the lines we made last time. Since 72 is an even number, we can start by dividing it by the smallest prime, which is 2. 72 divided by 2 is 36. You write 2 here and 36 here. Can we divide 36 by 2 again? Yes, because 36 is even as well. 36 divided by 2 gives us 18. So you write down 18. Now check again. 18 is still even, so we divide by 2 one more time. 18 divided by 2 is 9. So you write the 9 down here. Now here's the catch. 9 is not even, so we can't use 2 anymore. Move on to the next prime number, which is 3. Can 9 be divided by 3? Yes, it can. So 9 divided by 3 is 3. You write 3 here and 3 over here. And 3, which we have here, is a prime number. So we divide it by 3 again, and now you finally get 1. Perfect. We've reached our goal. Now let's write down the prime factors. 72 is equal to 2 times 2 times 2 times 3 times 3. And if you're asked to write this in exponential form, count the number of 2's. There are 3 of them. So you write 2 raised to the power 3. Then there are 2 3's. So you write 3 raised to the power 2. So your final answer is 72 is equal to 2 raised to the power 3 multiplied by 3 raised to the power 2. That's it. See, you're getting the hang of it now. Let's make things a little more interesting. The number we'll factorize now is 68. You'll understand in a while why this question is a bit more interesting than the ones we did before. Write 68 down and make the lines. Since 68 is even, start by dividing it with 2. 68 divided by 2 is 34. So you write 34 here. 34 is still even, so divide it by 2 again. 34 divided by 2 is 17. Now, 17 is an odd number, so we try the next prime number since we know it can't be divided by 2. The next prime number is 3. 17 can't be divided by 3 either. So let's try 5. Nope. What about 7? No again. Eventually, you'll realize 17 is a prime number itself. So we divide it by 17 and we get 1. And now you're done. Now let's write the factors. 68 is equal to 2, multiply by 2, multiply by 17. If we are writing it in the exponential form, there are 2 2's and 1 17. So we write 2 raised to the power 2 multiply by 17. Our final answer is 68 is equal to 2 raised to the power 2 multiply by 17. So with maths, you can never be sure that you've understood the concept until you practice it yourself. So that's why it's your turn to do some prime factorization. I want you to try the number 54. Start just like we did with the other examples. And there we have it. You won't have any trouble with prime factorization now. If you enjoyed this lesson, make sure to give the video a thumbs up and share it with your friends who might need help with math. Of course, don't forget to subscribe to the channel so you don't miss out on more math tutorials coming your way. That's all for today's class. Don't hate math, keep practicing, keep learning, and I'll see you in the next video. Bye-bye.